Structural health monitoring, or SHM, is a critical field that ensures the safety and longevity of our infrastructure. Imagine a bridge that can tell us when it's feeling stressed, or a building that alerts us to potential weaknesses. This is where artificial intelligence, particularly machine learning, steps in to revolutionize how we monitor and maintain our structures. At its core, SHM involves collecting data from various sensors embedded in structures. These sensors track parameters like vibrations, temperature, and strain. But simply gathering data isn't enough. This is where machine learning shines. By analyzing vast amounts of data, machine learning algorithms can identify patterns and detect anomalies that might indicate structural issues. There are several types of machine learning techniques used in SHM. Supervised learning, for instance, relies on labeled data to train models. It's like teaching a child with flashcards. You show them examples of what a healthy structure looks like versus a damaged one. Then there's unsupervised learning, which finds hidden patterns in data without prior labeling. This is akin to exploring a new city without a map, discovering insights as you go. Real-world applications of AI and SHM are already making waves. Take the San Francisco-Oakland Bay Bridge, for example. Engineers use machine learning algorithms to analyze data from sensors that monitor the bridge's health in real time. When unusual vibrations are detected, the system can alert engineers to investigate further, potentially preventing catastrophic failures. Another fascinating example is the use of drones equipped with AI to inspect hard-to-reach areas of structures. These drones can autonomously analyze images and data, identifying cracks or corrosion that might go unnoticed by the human eye. This not only enhances safety, but also saves time and resources. The implications of AI-powered SHM are profound. Imagine a future where our buildings and bridges are not just static structures, but intelligent systems that communicate their health status. This could lead to safer cities, reduced maintenance costs, and extended lifespans for our infrastructure. In conclusion, the integration of machine learning into structural health monitoring is transforming how we approach engineering and safety. As we continue to harness the power of AI, we're not just building structures, we're creating resilient systems that can adapt and respond to the challenges of the future.